I have been tracking neural networks for a long time, and I got to tell you, it's very exciting. It is a very fast-changing field right now. And if you listen to what everybody else has been talking about, you'll hear where there has been a lot of work. It is hard for us as a hardware vendor to keep up with making sure that we support as many different new engines, graphs, and frankly, I was astounded when I saw a demonstration recently of 20 frames a second image recognition. It was MNIST, I think, running on a Cortex A7, and it just floored me that it can be done that well. I'm not here to talk about all that. I'm here to talk about, after all the work you do in building, first understanding the graph, building your corpus, and then figuring out what data you want to manage, where are you going to run it? And how are you going to build a device that actually represents what you want to run your engine on? So this is really not about anything to do with training. It's everything about how you run your inference engine and what the hardware is that you run it on and how you make decisions about that. Let's fix this. Okay, so last year, this is what we talked about, how to create IoT devices for rapid deployment. This year, I'm talking about how to deploy edge AI devices specifically. I'm going to show you what we've done, what we've got as test cases that we've done internally, specifically using 3 boards. One is the Jetson. I assume you're all familiar with the Jetson TK2. It's an NVIDIA. It's got 256 CUDA cores. DragonBoard 410C is a Qualcomm 410, and the Raspberry Pi compute module is a Broadcom. So 3 different architectures, but all designed, processed with Geppetto. In order to validate our process, first thing we did, and this was eye-opening for me, we hired Kenny. Kenny is a high school student in the Bay Area. I asked him what he'd been doing, and he just finished 11th grade, and he was familiar with TensorFlow and had done a bunch of models on it, MNIST, et cetera, and in fact had done some generative designs using TensorFlow. So we thought this was a great summer hire, and this is what he did in the course of a couple weeks working for us. I think 6 weeks. So I'm going to do the whole demo quickly. Let me see if I can speed it up, because we don't need to speed. We're going to double speed here. So what you see, this is the iCreate. It's a Roomba platform that takes care of all the running around. And so what we did, we hooked up a Jetson on top with vision recognition. And this thing is visually servoing. Does that mean anything to you guys? So it's at 20 frames per second. This thing is calculating where there's somebody in the room, and it's turning so that it hits him and keeps following him. So this is the old line tracing algorithm, except instead of line tracing, it is doing real-time image recognition and tracking. So the whole control loop, and this is him following down the hallway. This is a high school student in 5 weeks. The capabilities of TensorFlow are being well understood, and they're being trained into kids very young. They know what neural nets are. They know what these things are. Anyway, so that's Kenny. So that was the demonstration. This was how we showed that we knew what we were doing in the board design. After that, we added control routines on the AeroCore. And this is something else we've been involved in for many years, making sure that we could run an autopilot. And we're in lots of drones using Geppetto-driven or Geppetto-designed boards. I'll talk a little bit about what Geppetto really is. But what we were able to do with Kenny's design was validation of the cameras, make sure that we had Jetpack and TensorFlow. COCO is a common object recognition. I'm sure most of you are familiar with it. We used there's a mobile version of that. So again, these are all off the shelf. Kenny had to put together the bounding boxes, and then he also figured out how to offload all this. So in addition to the recognition and the tracking on the board, he was able to publish it in a way that people could subscribe and have other processes being driven by the recognition, and then the servoing at 20 frames per second. Then we added MAVROS, which is, are you all familiar with ROS, Robotic Operating System? So this is a connection for MAVROS. It is a way to do Q ground control of drones, and is by far the most widely used open source drone control system. And so after we had shown that we could do that, we connected up. I'm not showing the connection to MAVROS, but this is on a drone able to follow, and he's doing visual servoing on himself as well. So this drone is now able to follow at 20 frames a second, is able to identify somebody on the ground and follow them. Recognize we're not a software company. This is application. This is widely available application space stuff. Our goal is to make sure that whether you want to build something that goes on to the Create or run a drone, that we can get you exactly the hardware you want in 3 weeks. And then something else we did just quickly, this is the same image recognition work repeated on another Gumstix Geppetto designed board. You can see a little Geppetto logo there by Gumstix, and that's running a Raspberry Pi compute module. And you can, you may not be able to see, this is running at 0.85 frames a second, so it's much slower than the 20 frames per second. We've also, so as I said, we've done this. We're right now working on it with the Hikey 960. Other aspects of the tool chain that we are including is this, everything that we heard about this morning next door, which is the ARM-NN CMSI, I don't know what the Cortex-M ARM-NN, and this abstraction layer outside TensorFlow, so that fundamentally, no matter what you program on, you can run it on a board that we build mezzanine cards or expansion cards or boards for. So anybody who's building Edge AI has got a bunch of inflection points in the design process for what they're building. First off, it's everything that we, again, talked about in the other room. What's the data path? What's the graph in the model? What is the engine that you're running? What's the model training that you're going to go through? But then fundamentally, you've got hardware choices. Are you going to run, we support everything from a Cortex M0 all the way to a Jetson TX2. The question is, what are you going to run, and how can you decide at the beginning what you're going to run on? What we do internally is we run high and then migrate low. But if you're a hardware designer and you want form, fit, and function experimentation with users, the idea that you could design a piece of hardware, experiment on it for 3 months, decide that you want to cut it down, and completely re-engineer the piece of hardware that you're running is inordinately expensive. And what Geppetto is all about is getting rid of that design choice. So what we have is an online design tool that lets somebody, from a marketing perspective, say, I want these features on my board. How am I doing on time? Okay, I want a set of features on my board, and ship it to me. Because one of the things that was said this morning, which is really true, as long as your software runs perfectly, you don't care what hardware it's running on. And what we try to do is make sure that somebody can say, these are the features I want on my board. They can design it quickly, and we will ship it to them up and running, booting Linux or Arduino in 3 weeks, beginning to end. And it's a simple, if you think from a software perspective, if you think of what object-oriented programming did to programming, what Geppetto does is it brings the same kind of modular design without having to look under the covers, and brings the reuse of code. Between now and the end of the year, we're running, instead of a $2,000 NRE manufacturing fee, we're going to give a 2-for-1. Anybody who builds a board can do the exact same board. For example, they may want to do the exact same board with 2 different computer architectures. So, for example, they might want to build something that's a 96 boards mezzanine, and they want a Raspberry Pi CM3 carrier board. They can do that in only one manufacturing NRE fee. Let me show you really quickly what it is that we do. And in order to do this, I'm going to sit down and drive. So for what we're looking at here, this is the module design of the AeroCore for the 96 boards, AeroCore for the DragonBoard. I'm going to click on this, bring it up. And this is the AeroCore 2 for the Jetson. And what we can see here is we sell the board itself. This is something that we give as an example board for $275 in the store. We can open the design. When we ship it, people get the board support package for it. We provide documentation for it. And this is, so we'll just take a quick look at the open design. We're going to clone it. Imagine, for example, somebody doesn't want to use a Jetson. We can delete the Jetson. We can do all sorts of things. But if I delete it, then we'll have a lot of connections to reconnect. You can see that we've got a CR wireless socket on it. We've got USB 3. We've got a CSI 2 camera. We've got 2 cameras, in fact, that drive they're CSI 2 that drive straight into the Jetson. If somebody wants to design a board or make a change, what they could do is click on this, delete it, and say, well, I need something else that drives one of these cameras. I need a CSI, and instead of using that, I can use, I took the Jetson off. I can put we'll put a Raspberry Pi CM3 Lite here. And when we put that on, we see that this still needs a boot device. It's a CM3 Lite. We'll put an eMMC memory on it. The camera connector needs a power down. We don't have power down. This camera connector here. So let's get rid of the one that's not supported. Oops, dismiss. And there's no USB 3 on a Raspberry Pi C. The next step is to connect everything up. I'm not going to bother doing that, but it's a matter of choosing this reset and getting it powered by this. The connector needs a cam 0 connector. This connector needs another one, cam 1. So it only supported the 2 cameras. This is something that once someone goes through and makes those top level connections, they would be able to order online, and we would ship to them up and running with, in this case, it would be a Raspbian implementation and a Yocto Debian implementation. I'm going to do a really quick example of, you're going to preview something that we're coming out with in a couple weeks. It's called the Board Builder. I'm going to say we want a new board. We've got a new board builder coming out. So somebody gets to say, I want let's say they want to do a nice simple Arduino design. I want an Arduino, and for sensors, I want a humidity sensor and a barometer sensor, no audio. I want memory's already there. Power, I want it to come from, I want a barrel connector. So we'll do a 5-volt 3-amp barrel connector. That's a big overkill. So now we're going to build the board. There we go. There's our board. And this needs okay. So we just did a checklist build of a new engineering board that is available with a parallel camera connector. It's an M0. I don't know that there is, in fact, a ARM-NN for an M0 yet, but we'll be able to swap that out with an ARM Cortex M7 shortly. In any case, so that's a little bit of what we're doing for the, how to build something quickly for the edge, how to run something simple, how to run something that's complex to build but simple to deploy, which is where we fit in the market. These are widely used now for prototyping situations and small volume manufacturers, meaning up to about 10,000 boards per year. We have customers who prototype commercial consumer devices on them, but obviously always want to take this as a prototype and build consumer devices on their own. Let me stop there and ask for any questions. Yes?
The form factor of the final board,
Mm-hmm.
I mean, it can only get so small, but do you have any ability to then customize the final?
You mean to do something like that?
So if you want to make it, you could actually, and then you guys just place it right with the.
Yeah, everything's customizable. Yeah.
Now, of course, you can only get so small, but
You can't get smaller than the pieces that are on it. And the one constraint, we haven't figured out yet how to make sure that we can put a straight connector on a round edge. So anything that's round can't have like USB at the edge, even though we will get there. Any other questions? Yes. Yeah, our customers range from military and government organizations to industrial customers, medical customers, and then a lot of academic labs use this for whatever an academic lab would want. Yeah. When we ship this, it's already been booted. So everything's been tested. So, so when we ship it, what I did not demonstrate here is, for example, all these have functions behind them. So we've got a power tree that we build up, module info. We talked about auto dock. It might be worthwhile showing what that is all about. Let's see if I can fit all these on here. Not enough, so what we're going to do here is I want to substitute we need 3.3 volts. We're going to pull this on. Sorry, here we go. Okay, so now I can save. You know what, I'll save it. So we in addition, so we've got something like a 3D image that you can download for interfacing with case design. And then we also have an automatically generated documentation, which is everything that you need in order to program this thing. Module connections graph, power graph. So for example, that's available. And then auto BSP. For those of you familiar with Arduino, you can see that this is everything that's needed for the Arduino. And then also we've created the endpoint. so that somebody can go on their desktop and download everything needed to run Arduino. CAD, this is a CAD interface board builder. So what we do once we generate the BSP is create a complete test suite that's functional test of everything that's on the board. So that's how we ship it. So when you get the board in 3 weeks, it's a finished board. It's ready to run, it's ready to program it, and in the meantime you can use QEMU or any other emulator you want in order to test code that you've developed for that system by downloading the board support package and running the device tree in whatever system you want.
The board support package, then, so all the peripherals that you're supporting,
Yes.
that would then include a driver
Yep.
for all the OSs that you support across the board?
Correct. Yeah. Yeah. That's one of the key inclusion factors. We are about to grow the number of modules available in here significantly, and one of the decisions that we've made is to relax that constraint. We will do things like put a great big, so for example, for humidity sensors, they're I2C sensors. Not all of them have got a Linux driver. So what we will begin doing is something, I think I've got some examples down here under sensors that we've got. Yeah, so we'll do something like this to show that for this 80XL accelerometer, we've got a Windows driver. So if somebody wants to put together a Windows driver system or a Windows 10 IoT, they know what to include, and we'll support those. It's unfortunate, but yeah, exactly. But luckily, it's really well documented which are in, which are not, and there are a lot of modules out there where customers have asked us for chips that do not have any drivers, and we have uniformly said no, and in 6 weeks we will start saying uniformly yes, and we will give a standard I2C SPI or whatever driver, and you can bit bang it yourself, but we don't have the Linux. We're not going to interface to GPSD for everything, for example. Anything else? Yes?
So I'm a software engineer.
Yeah.
If I have a crazy project,
Yeah.
what should I expect in terms of fail and retry? I mean, if I do a design, is there a system engineer on your side that says, okay, we've been submitting this design, and
When you submit a design, it will come back working. That's it.
but so you have some guys that
Yeah. Oh yeah, this is not entirely automated. I'll say there are exactly two things that our engineers do. You can say that I'll turn it around and say everything is automated except high-speed trace routing, and then QA. So we do have QA of the design. We have an engineer, a layout specialist, make sure that the traces are routed correctly. So that's number one. And then number two is once it's done, we have somebody inspect to make sure that it makes sense. So every once in a while, we've had somebody design a board where they had a right angle LED that they faced internal. And so we pointed that out, and it was a quick fix. But it's simple things like that. And our whole verification button there is intended to automate simple things like that. And as people make mistakes that are entirely acceptable electrically, but not logical. For example, no reset button. So it's okay not to have a reset button, but you really want one. No mounting holes. You should have one. You've got a choice where to connect the console output. Did you really want it on a USB to serial, or did you rather? So we make sure somebody verifies that the console goes to the right port. So there's certain logical things that are really design related that are really design related that may or may not be right that we can verify.
So a non-technical one. To me, it looks like insane, but in a good sense. That's
Yeah.
But so you probably have a massive amount of experience of hardware designs that you condensed into that.
Yes. So we started in 2000. Yeah. So we started in 2003. Actually, we started before that, but our company was launched in 2003. We did the very first we did the very first Linux on a SOM, before there was the name COM or SOM. So the start of the company is we did glibc, so a full memory managed implementation of Linux on something the size of a stick of gum, and that's what we've been doing for 15 years. And then all the expansion boards. And originally we were an open hardware company, meaning that we would sell you the COM, but we would provide you all sorts of hardware designs for free, free and open source, hardware designs for the expansion boards. And that's how we kept in business. And then one day somebody realized, we should just put this all the automation that we had done internally, put it all online as a web app. So it is now, Geppetto's our free web app. And we only charge for the hardware that we ship. Anything else? Thank you very much. Yeah, thank you. See, I had plenty of time, so it worked out. Yeah.